Okay, so notice what the directions are saying. They're giving me an x value, and they want me to estimate the slope at this particular x value. So what you're going to do is, first of all, we're going to find negative 8 on the x-axis. So negative 1, 2, 3, 4, 5, 6, 7, 8. So here's negative 8. So now, on the graph, I'll identify the point where x is equal to negative 8. And what I'm going to do is I'm going to draw a small tangent line. So compare the line that you drew with the horizontal. Think about in relationship to being a 45-degree angle. Is this tangent line close to being 45 degrees? So remember, you're comparing 45 degrees because that's where your slope is equal to 1. So we want a reasonable estimation. So if you wanted to, you could extend your tangent line out. If you wanted to get a better approximation, let me erase that because I was... There's negative 8. So there's really two ways you could go about this. Those of you that want things to be exact. You need 2 points on a line to calculate the slope. So here's my 1 point. You could identify another point on that tangent line you sketched and do your rise over run. The problem is this isn't exactly at negative 8, so you're going to have to estimate it anyway. That's why the quickest way and the easiest way for you to get used to doing this, draw your tangent line and then compare it with the 45 degree, compare it with the horizontal. So where's tangent line? If I imagine it with the horizontal, is it pretty close to being a 45 degree angle with the horizontal? Yes. So we could say the slope is approximately equal to 1. Now, every single tangent line that you're going to sketch, remember what you're comparing it to. You're comparing it to this particular slope, which you said has a slope of 1. So now let's go through and let's go ahead and look at negative 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So I'm just going to go ahead and erase this. That's why pencils will be your friend. So now if I look at the point on the curve at negative 5, and I sketch this tangent line. In comparison to the tangent line you sketched at negative 8, is this a steeper line? Is it steeper? Yes. So what does that tell you? So whatever slope we set at negative 8, you better give me a bigger number than what you gave me at x equals negative 8. So what would be a reasonable approximation? Is it really that much steeper? No, it's a little bit steeper. So what would be a good approximation or good estimation for this particular slope? Or 2, or you want to say 1.5 or 2? I just usually stick with whole numbers. X equals negative 3. So at x equals negative 3, what kind of tangent line am I actually drawing? It's what kind of tangent line? It's going to be what? Horizontal. And what kind of slope does horizontal lines have? 0. X equals 0. First of all, is that a negative or a positive slope? Negative. It's a negative slope. Now, if you compare it with the horizontal, it's a little bit larger than a 45 degree angle, would you say that? So what would be a good estimation for then the slope at x equals 0? Negative 2. Now, we can go back. Once we finish filling in the chart, we may need to readjust a little bit. Again, it's wherever you kind of start, and you're going to do a comparison. It's the steepnesses you're looking at. So in your diagram, wherever it's the steepest should have the largest slope. Got it? So now let's take a look at x equals 1. So at x equals 1, what can you tell me about the steepness of this negative slope compared to x equals 0? It's steeper. So I said the steepness, or the slope for part D, was negative 2. I would say it's a little bit more steeper than negative 3, wouldn't you? So what would be a good possible reasonable approximation here? Negative 4. If you said negative 3, I wouldn't take off. As long as there's nothing else, it's going to be steeper. Again, look at the steepnesses in your final answers. All right, let's look at x equals 2. Is the slope still negative at x equals 2? Is the tangent line at x equals 2 steeper than the tangent line at x equals 1? Yes, so you better make sure that you compare it to negative 4. I would probably say it's even steeper than a negative 5. So what would be a good reasonable estimation? Negative 6. Are we over the idea these are going to be exact? Okay, we're over the idea these are, again, these are reasonable estimations. Reasonable estimations. Again, you're looking at the steepnesses. You're comparing the steepnesses. Let's look at x equals 3. Do you have a problem at x equals 3? It doesn't exist. It's just a point. It's got to be a tangent line to the curve. So it's a DNE. X equals 4. So again, find the point on the curve at x equals 4. Sketch your tangent line. So am I looking at a slope of a positive or a negative? Positive. Compare it with your other two tangent lines that have a positive slope. The tangent line at x equals 4, is it steeper? Yeah, so you better make sure whatever the steepness you say, compare it to what you've already done. So you've already set a slope of 1, slope of 2. Compare it to the tangent line at x equals negative 5. It's much steeper. So what would be a good approximation when you compare it to a slope of 2? I would say definitely bigger than 3. I would say probably 4 or 5. Or 6. Again, reasonable approximations. X equals 7. 5, 6, 7. Did I count that right? 3, 4, 5, 6, 7. So here's 7. Draw my tangent line. Is this slope positive or negative? Positive. You've already set at x equals negative 8, you have a slope of 1. Notice this tangent line is getting pretty close to being a horizontal. So what would be a reasonable approximation for the slope of the tangent line at x equals 7? 0.3 or a fraction. You could say 1/3, 1/2. I would say something smaller than a half. So 1/3 would be good. If you said 1/4, that would be a good approximation. Again, you want a reasonable approximation. Okay? So when you go and look finally at what you've just said, what you've said is obviously 0 is where you have your horizontal tangent. The steepest slope on the positive side is occurring at x equals 4. So at x equals 4, that's where your tangent line is the steepest. At x equals 2, that's where you have the steepest tangent line with a negative slope. All right, so make sure. So now, how would you answer this question, J? Arrange the slopes from the smallest to the largest. Well, what is the smallest x value that has your smallest slope? It's occurring where? It's occurring at what? X equals 2. Because x equals 2, you had a slope of negative 6. Then what is your next smallest slope? It's occurring where? X equals 1, because we said that had a slope of negative 4. The next one would be occurring where? X equals 0, because we had a slope of negative 2. And then after negative 2, which is our next smallest slope? I think that takes care of all the negatives, doesn't it? So then we had a slope of 0 at x equals negative 3. After 0, what was our next smallest slope? X equals 7, which was 1/3. And then we have at x equals negative 8, the slope of negative 1. and then we said it was at 2, x equals -5, and then finally we had x equals 4, and we said that had a slope of 4. So when you're checking your answers tonight, ladies and gentlemen, I said this was a slope of -6. You may have said it was -5. Still a good reasonable approximation. You may have said -7. You may have said -7.5. You may have said you're still in the ballpark. They are still good, reasonable approximations. Yes?
What's the highest slope?
I mean, you could go to 100. I mean, you could go to 1,000,000. But that you're looking at almost a vertical line. I mean, you can make it as steep as you want. But again, if you're saying something that number, you're looking at almost a vertical line at that point. But just be careful, it's not quite vertical because vertical lines have undefined slopes. Yeah. Okay? So let's take a look at another example. Now let's take a look at another graph. So here is a graph that shows the height in centimeters versus the age in T years of an individual from birth to age 20. What is the average growth rate from age 5 to age 10? So you can also relate what we did with average velocity to other applications. This is why when you go to college, it's not just math majors that take calculus. Business majors have to take calculus because you can use a lot of these calculus applications in a lot of other fields. Growth rates of sales, average rate of growth, this is what we're talking about. So we look at the average growth rate, and again, relating it to what we're doing with slope, what we're doing is we're looking at the slope of the secant line. Just like you did the other day when we were talking about average velocity over a time interval, here we're looking at an average growth rate over years. So on my graph, at age 5, I have this particular point. There's my point at x equals 5, or at age 5 years. At age 10 years, so again, I can, using my ruler, I can sketch the secant line. So you're going to have to approximate this. So at age 5, what appears to be the height? What appears to be the y value at age 5? Give me a reasonable approximation for what the age is at age 5. 110. If you said 115, that's good. If you said 105, that's good. Reasonable approximation. So then at age 10, what appears to be the height in centimeters? 140 would be good. So now that I have the age and height at those particular years, I can calculate the average growth rate by simply finding the slope of my secant line. So I can take 140 minus 110 over 10 minus 5. So 140 minus 110 gives me 30 over 5. So that's going to simplify down to what? 6. You have to have units. Well, in the numerator, it's the y value that's in the numerator. What is 140 and 110 in this particular problem? What was the units? This is talking about the height. Centimeters. So this is going to be 6 centimeters per, what's the units in the denominator? Years. So 6 centimeters per year. Make sure you include your units. Okay? Any questions on how I found the average growth rate? Now, another way they may ask this tonight on your homework is they'll ask you about average velocity. So they may give you a graph. They may ask you to find the average velocity. You do it exactly the same way. They've got to give you a time period. So all you're doing is you're calculating the slope. Average growth rate, average velocity. Again, anytime they ask you about average, you're just doing the slope. Any questions on that? When is the growth rate the greatest? You're looking where you have the steepest slope. So I'm just going to erase where I already sketched over. So where does it appear from this chart? Where does it appear the slope of your tangent line is the steepest? Again, where does it appear you would have the steepest slope? Or right here.
I don't know. For like first 2 years. Yeah.
I would still say this is a little bit steeper. Yeah, it's a little bit steeper. Yeah. So about somewhere around 13 to 14 years. Again, and really what you want to do is actually sketch those small tangent lines to be short. Estimate the growth rate at age 5. So this is going to ask you just simply for the slope of the tangent line. So if they want me to estimate the growth rate at a particular number, just like you did with the velocity problems, we had to find the instantaneous velocity. So another way they may ask you from a graph is find the instantaneous velocity at a particular point. All you're going to do is find the slope of the tangent line at age 5. So right here, just like what we did, here's the point at age 5. Sketch your tangent line for age 5. Compare it with the horizontal. That's a terrible tangent line. I'm trying to make the points bigger so you can see it. So at age 5, guys, what appears to be the slope of that particular tangent line? Is it about 1 or a little bit larger than 1? A little bit larger than 1. So what would be a good reasonable approximation? 1.5, or could we say 2? Yeah. So 1.5 to 2. So probably about 2 centimeters per year. I'm sorry? Oh, you're right. You're right. You're absolutely right. Yeah, so it probably would be a little bit larger than 2 then.
I got 8.
8? Okay. Yeah. Okay, shh, guys. At approximately what age, between 10 and 20, is the growth rate the largest? So I think we already answered that. Where is the growth rate the largest between 10 to 20 years? 13 or 14 years. So we got to pick one. 13. So probably about 13 years of age. Because that's where your slope is the steepest. Estimate the growth rate of this age. How are you going to do that? You're going to simply do what? Find the what? Find the slope of your tangent line. And part E we're actually going to do in 2-2. All right? We're actually going to go backwards. Given the graph of the function, we're actually going to then go backwards and find the graph of the derivative. So remember, guys, only page 140 is the homework due for next class.
Are we going to take 30 minutes to do 140?